Hey everybody, it's Scott from Texas Prepper Projects, and I've got something really fun and exciting for you today. So we are going to build a sand battery. And I did not come up with this idea, not by a long shot. I'll link to the video below where I got this idea from. I've been doing some experiments for the last couple of days on some small scale, and I'm ready to build something bigger. So what is a sand battery? A sand battery is exactly what it sounds like. You use a quantity of sand and you use the sand to hold heat. Now, why would you do that? Well, water obviously taps out at 212 degrees Fahrenheit before it turns to steam. You can heat up sand to several hundred degrees before it melts. So you can hold a lot more energy in sand than you can in water. And also sand is really cheap. A 50-pound bag of sand is $5. So what can you do with that heat? Well, you can do a couple of things. You can use it to hold heat and use a thermoelectric module to create electricity out of, actually. And in some larger scales, people are testing using it for solar and wind farms instead of chemical batteries to turn into heat and then turn back into electricity at night. What I'm going to use it for, or attempt to use it for, is as a gigantic radiant heater. So we are now in January here in Texas, and we got through our first big cold snap. But our snowpocalypse 2 years ago hit in February, so we're not out of the woods yet. I do have a Mr. Buddy heater that runs on propane, which I feel good about using indoors, but there's nothing safer than a big bucket of hot sand in the bedroom or inside the house to radiate some heat. So that's sort of my purpose, is as a non-toxic, renewable indoor heater. And renewable is the key there, because my master plan is to power this thing using my solar panels. Okay, so how does this work? So I've got a big pot, obviously filled with some sand. This is about 10 pounds worth. And buried inside of here is the heating module from a water heater. They cost about $10 on Amazon. I'll put a link to it. And I've got a little wire terminal sticking out with some Anderson power poles. So the water heater module is buried about an inch off the bottom. This is a meat cooking thermometer, which taps out at 220 degrees. And when I applied 60 volts at 4 amps to this module, the bottom of the unit, the bottom of the bucket of sand got so hot that this needle wrapped around like a clock in fast forward. So that's greater than 300 degrees. At that point, the surface temperature was about 110 degrees Fahrenheit. So this whole thing was well over 100 down to 300 towards the bottom. And it held that heat for about 4 hours. So this whole thing was radiating 100 some odd degrees for about 4 hours. So let's ramp this up. Here in front of me, I have a very large cooking pot that I got out of a junk pile. I was going to use a galvanized metal trash can, but this was free. Now, based on my preliminary experiments, I lost a lot of heat from the bottom. Down in the bottom is about 3/4 of an inch of plaster of Paris. So hopefully that ceramic will help insulate the bottom and push the heat upwards. I'm going to put about an inch of sand in the bottom and then bury the temperature probe from a thermometer that I've got down in the very bottom, so I can kind of keep an eye on it. These came from Amazon, and I know that they max out at 190 degrees because this actually errored out in my preliminary testing. Oh, geez. So while digging out the probe, the hot water probe from my test bucket, it appears that in the surrounding areas next to the probe that pieces of sand got so hot that they actually fused, because there's some solid chunks down inside here. So that's what the probe looks like. So I'm going to put this about the halfway mark. And keep on going. So I have an idea on how to create a lid for this pot. So before I fill it up the rest of the way, I'm going to put a rim of paper around the top to protect it, and I'm going to fill it up with plaster of Paris. So this now has 50 pounds of sand inside of this bucket. So I'm going to put this cardboard form that I made down the bottom and fill up the top with plaster of Paris, about an inch or so, and make me a little lid. So here's the inside, and I have the wires taped down. Here's my concrete cardboard form, which is far too big. And right smack in the middle, I'm going to put a hole and stick a soda straw in, so that way I can put a temperature probe all the way through and actually get down into the sand. There's my soda straw. I think I'm just going to go for it. I think I'm just going to pour the plaster in and then just sort of bang the sides and see if I can get it to break loose. So let's see what happens. Okay, let's make some plaster of Paris. Since I've already done this once, I know about what it's going to take. Pro tip, plaster of Paris is significantly cheaper at Hobby Lobby than it is on Amazon. This is an 8-pound bag, it was $8, and I'm going to use up every bit of it. So just for reference, the bottom layer, which is about 3/4 of an inch, is 4 of these cups and 2 cups of water. I've only got enough left to do one batch, which is 2 of these and 1 cup of water. And that was 8 pounds. So we've got the power wire for the thermocouple, or the heat module. My thermometer over here. I got a straw for my other temperature probe, and my little handles. And let's frost a cake. Hey, the shake method worked really well. This batch isn't as watery as the batch from yesterday, but just giving this a little shake helped it all kind of settle out. So we've got at least some layer of coverage. Now, when I did this yesterday, it took about an hour for it to reach any sort of solidity, but you're not supposed to touch it for 24 hours. So it's 2 o'clock now. We'll come back in 2 hours and see what I did. So we got it going. The plaster Paris has dried. I have got 60 volts at 4 amps, so 240 watts going into this. And in 15 minutes, the bottom has gone up 4 degrees, and the top is at 102 and climbing. This is my data logger, so we'll be able to track it every 5 minutes. Here's my meat thermometer. I don't know which one I trust more, but we'll be back. It's now 5:15. We've been running for an hour and 15 minutes. And the base is at 165 degrees. And the top is at 514. Well, I can feel heat on the bottom now. Still at 240 watts. Unbelievable. It is 7 o'clock. This has been running since 4:30. The thermometer that is down buried at the base of the unit has maxed out my little cheap thermometer, so it's greater than 200 degrees. My brand new 500 degree meat thermometer maxes out when I stick it inside this hole to hit the sand. So the sand at the top is greater than 500 degrees. According to my laser thermometer, here in the center, the plaster of Paris is 120 degrees on the middle and 75, 80 along the outside. The side of the pot is now functionally warm. Like if you touch it, there we go, there's a warm spot about 90 degrees. I'm still holding at 60 volts at 4 amps, 240 watts, which is easily achievable. Yeah, when I put my hand here, it is warm. I can feel heat. And that's only 2.5 hours in. I've got 2.5 hours to go. So this is rocking and rolling. This is really incredible. So we'll check back in another hour or so and see where we're at. Hey everyone, it's the next day, and I thought I would recap on what we did and what we learned. So where we left off, it had been running for a couple of hours. I never did follow up on it. I didn't make a follow-up video because the temperature hadn't really stabilized and it was getting late. So what did we do? So I took a pot, put a layer of ceramic down in the bottom, plaster of Paris, put 50 pounds of sand in the middle with a hot water heater element in the middle, and gave it 60 volts at 4 amps. Now those numbers are important because, as you saw early in the video, I have two 35 volt residential solar panels that I got off of Craigslist for about $100 a piece. So if I put those in series, that's about 70 volts. So for $200, I can generate 70 volts at 6 or 7 amps. That means I can run this whole thing on solar fairly inexpensively in the backyard and generate an insane amount of heat. How much heat? Well, my equipment died. My indoor-outdoor thermometer in the bottom of the bucket was well over 200 degrees because that's where the thermometer stops. The top layer of sand was over 500 degrees because that's where my meat thermometer stops. The plaster of Paris was between 100 and 130 around the top, the lid that I made, and the sides were around 90-ish degrees. I don't know enough about thermodynamics to know if I would have been better off pulling the plaster of Paris lid off and letting the heat completely radiate out of the sand, or cutting a little slit. I'm sure that a mechanical engineer will help me with the thermodynamics of all of this. But the power requirements and the time is really interesting. As I said, I was going to run this on solar. This thing heated up in 3 hours. And that's a really important number because most places in North America get between 4 to 5 hours of direct sunlight. So since I said I was going to talk about solar, in Texas we get 5 hours of sunlight, and I have my 2 solar panels. That means during the day, when I have 5 hours of direct sun, I could get this bucket of sand up to several hundred degrees and then bring it inside at night and let it slowly radiate that heat out at night. So what are the conclusions here? This was a fun experiment. You know, I've been doing some small scale stuff over the last couple of days, trying to kind of get my head around this and make the build a little better. It's a really interesting idea. As I mentioned in the very beginning of the video, I was going to try to use this to replace my Mr. Buddy heater. I think where this is going to have its most benefit would be inside what's called a microclimate, which is basically a tent inside your house where you're trying to trap the body heat of your family or your pets into a smaller area. Because the outside of the pot never got over 100-ish, you know, it's not hot enough to burn yourself on. Although I did actually burn my fingers on the metal of the temperature probe that I pulled out of that little hole I made in the plaster of Paris. I actually burnt my fingers on it and took my fingerprints off. It was that hot. But the body got to around 100 or so. So I think this would be a really good way to like slowly radiate out some heat in a method that is safe and doesn't produce CO2, doesn't use fuel. You know, your cost, you know, a buddy heater is about $100 and the tanks are about $5 or $10 a piece. So let's say you're in it for 150 bucks. For this, you know, a small trash can is about $20. 50 pounds of sand was $5. The temperature probe was about 10 bucks. The plaster of Paris was about $8. And then the 2 solar panels, maybe 200. So you may be able to, I don't know, say replace a Mr. Buddy heater, but certainly supplement it for a couple $100. Not worry about gas, not worry about storing chemicals, not worry about CO2 or anything like that, and have a great big thermal mass that is renewable and solar powered. Now, if you don't have sunlight because your winter storm is so bad, you could feed this with any other sort of electricity. You know, I've been doing this in my garage off of a big power supply with a voltage step-up adapter. You know, you could feed this with 110 if you had a generator. That's what it's designed for. At 110 volts, that's 1100 watts. I think you might hit a point where you'd have some component failure. I would probably beef up the wire size, because as your voltage goes up, your current goes up. So you're going to be pulling 11 amps at 110 volts. So that's residential power level. So I would increase the wire size. I can't imagine getting that whole bucket from top to bottom up to a couple of 100 degrees. That's almost scary. You know, getting a thing up to 100 around the outside was still pretty impressive. And I actually really liked the handles on the side. You know, that cauldron is made for, you know, boiling shrimp or something like that. So it was a good vessel, and I think a stronger vessel because it's one solid piece than the $20 galvanized trash can from Walmart that I was originally going to use that may eventually rust out across the bottom, something like that. I also have put it on some pieces of hard pink foam insulation to get it up off the ground. But in my preliminary testing, I learned that pink styrofoam insulation melts at 300 degrees, will collapse like styrofoam, which is one of the reasons why I decided to insulate the bottom. So I took my thermometer and shot the bottom. The very bottom where the plaster was didn't get that hot, so I'm not overly worried about like melting my carpet in my house or melting the bottom of a tent in my house. But I would still put it on something. I would still put it up on some 2x4s and just don't have it directly touch anything. So this is a really was a fun experiment, and if you have any suggestions about how to maybe make this better or more efficient, I'd love to hear it. I have some ideas about taking the plaster of Paris off and putting like aluminum vent fan, aluminum fins in it, like an actual heat sink from a CPU, to see if I can get the heat to radiate outwards a little bit better. So if we have another cold snap here in Texas, I may do a Rev 2. So send me your thoughts and your comments down below, and we'll see you on the next project. If you're enjoying this content, please give me a thumbs up, a like, and a subscribe. Building a channel base is really important to YouTubers, and it also helps motivate us to keep making content. We love seeing those tick marks go up. So if you enjoyed this and found this fun, make sure you give me a like and a subscribe, and we'll see you on the next project. All right, thanks everybody.